Good afternoon, everyone. My name is Ditte, and I'm very pleased to welcome you to today's SHM webinar. It's really great to see so many of you joining us right now. And as you know, Dr. Peter Andersen will be leading the session, and he will begin shortly. But before we get started, I would just like to go over a few practical points. First of all, you are very welcome to ask questions both during the presentation and afterwards. But please note that the microphones and the chat function in Teams have been disabled, mainly to avoid background noise and pop-up notifications. So instead, I can kindly ask you to use this Q&A function to submit your questions. Palle will address technical questions at the end of the presentation, but if you have any questions regarding license options or commercial matters or anything like that, please also use this Q&A function, and I will be happy to respond to those. And I can see that we're still admitting a few people, but we'll just start the session shortly. And with that said, I think I'll just hand it over to Palle now, but enjoy the session. Thank you so much.
Thank you very much, and welcome to this webinar. It's 3 o'clock now here in Denmark, and we'd like to get started here. This webinar here concerns vibration-based structural health monitoring using our software model, ARTeMIS Modal. And I think it's around 1 hour or so that I'll be talking, so let's get started with it. The outline here for this presentation here is, as you see here, there is going to be a little introduction here to vibration-based structural health monitoring, and then I would like to focus a little bit on the parts that relates to operational mode analysis and talk a little bit about the different tools and things that we have developed for this part, you could say, of the health monitoring. And then a little bit specific in the long-term monitoring section here using ARTeMIS Modal Pro, I like to address the different plugins we have and how they actually should be put together, you could say, to form the package that we are offering and how to use it. And then I have a section here where I will try to focus on how we can have maximum use, you could say, of a license that you have of ARTeMIS Modal. How can we actually make maximum use of it and do it in a way so we do not have to interfere with the actual analysis when we want to use or look at results and so on. I would also like to talk a little bit about a more lightweight version, you could say, for long-term monitoring. This is our command line version of ARTeMIS that we have introduced here within the last week. And then finally, I have some final remarks that I would like to give. And then after that, we can have a session with some questions and answers. And I think, as Ditte said, please use the Q&A function in Teams in order to write your questions. Some of the questions might even be answered before I end this presentation here, but otherwise I will try to catch up in the end. Okay, so let's get started with the structural health monitoring, particular vibration-based. I'd like to underline that because structural health monitoring is a lot of things. It's not just measuring and analyzing vibrations. It is much more than that. But the things that we are focused on in this company here and with our software is to analyze measured vibrations and then produce one thing, you could say, or primarily one thing, and that is modal parameters. Modal parameters are some distinct parameters that actually describes like a fingerprint what's actually going on in a structure at a certain time where you are measuring it. And because of this, you could say, very specific information that is, you could say, linked to an actual state of the structure, that means that you can actually measure on another state and then try to extract these modal parameters. and then look for if there are any changes between the two sets or many sets of parameters that you have obtained. If these are changing, it can mean different things, but it can actually mean that there is some kind of cracking or damage happening to the structure. It can also be other things that I'll come back to. But it's, you could say, the primary reason for doing continuous monitoring and continuous mode analysis, that is to simply study if these modal parameters, they are changing or not. Mode parameters is, you could say, different set of parameters. If we look at a modal analysis of a structure in ARTeMIS, then typically we will see that we will have the most distinct part of it shown here. This is a mode shape. So this is one of the mode parameters, which is in fact a vector of numbers. And besides that, we also have a natural frequency that is normally listed here in this mode list here. And there is also a damping ratio. So together, these three parameters, they describe a single dynamic mode. And a structure has many dynamic modes. Some of them we can find, some of them we cannot find because they are not excited or they are outside the range we are measuring in. But the ones that we can find will always be a set of three parameters that we will be looking at. So this is modal analysis and what you can get when you do that from measurements. When it comes to long-term monitoring of a structure that is out in Mother Nature somewhere, we cannot really use the classical way to do modal analysis where you have some kind of device that can produce some forces and some other devices that can then measure how the structure responds to these forces that you are supplying. This is what we call experimental mode analysis. You cannot really do that because you have no control over what's going on in the nature. So we have to switch to the other type of technology that we have that is called operational mode analysis. In this technology here, we are only measuring the response at certain locations on the structure. And then from those response locations, we can now extract the modal parameters. So this is called operational mode analysis. And in short, we call it OMA. And there are many different methods available. In our software, we have two categories of methods. We have some frequency domain methods that are relying on peak picking on spectral density derived functions. And then we have another category that is working in time domain that we call stochastic subspace identification methods. And when we talk about structural health monitoring projects, then we like to use the stochastic subspace identification methods, the SSI methods. And there are different reasons for that. There might be more than what I'm listing here, but one of the things that we prefer is that it's a time domain method. That means that we do not transfer the data that we have recorded to another domain and then extract the modes there. We stay in the time domain where things has been recorded, and that actually allows us then to avoid some of the systematical errors that are produced when you switch to frequency domain. So time domain methods like the SSI methods can actually provide us with asymptotic, unbiased modal parameters estimates. And that means that when we say unbiased, it means we are not having any systematic errors caused by, for example, leakage and so on, that otherwise would be there in frequency domain. Another thing that we like about the SSI methods is that we are actually able to not only estimate the mean value of the modal parameters, we can actually also estimate, you say, the errors that are associated. Here I call it covariance. That's the measure, you could say, of errors or uncertainties of the parameters. So this is one of the nice features of the SSI methods, that you don't just get estimate of modal parameters, you also get a kind of a quality measure that you can use for different things, that tells you something about how much you can rely on these results here. So this is the so-called UPCX method we have in our software that has been designed with the uncertainty estimation also, which is the one that I normally prefer to use. Another thing that SSI algorithms are good at is simply just to estimate modes, no matter how the structure is. If you have a structure that is, you could say, a rectangular plate, for example, you will have well-separated modes. There, no problem. If you have something that is more, dimensions are more the same on different parts of the structure, then you can have closure space modes. And then if you have something that is completely symmetric, you will have what we call repeated modes. That means you have different modes at the same frequency. So you can imagine if you have a completely symmetric high-rise building, you will have two modes, one going in one direction and the other one perpendicular to it, having two different mode shapes, but having exactly the same natural frequency. So in this way here, using the SSI methods, we have a nice flexibility. We do not have to care so much about how the structure actually is, because we are sure that these methods here, they can actually work with the data. The last thing is that the SSI methods, you can actually make them work by themselves, more or less. That means we can run them automatic when we have set it up, how we want them to work. They can actually work on their own, even though some things change in the data as we go along with measuring on the structure. Some modes might be more well excited than others, so there will be a little bit of change of the way that modes are composed in the structure, and also how much noise we have. The SSI methods are actually able of compensating for this to a large extent, and that makes it a really robust tool to use for this long-term monitoring. So that's a little pep talk around SSI, why I prefer to use these tools here for, you could say, long-term monitoring. Another thing we have to do is we have to in some way be able to see if we have these changes of our modal parameters. And the way we like to do it is to make some kind of diagram that basically looks like what we call a stabilization diagram we have put in the wrong direction. So now we are looking at how modes are changing over time. So as long as they are horizontal lines, everything is good. The minute you start getting up and down in this one here, it is an indication that something is changing. So it's quite clear when you have this type of behavior. And you can see here a diagram like this where we have 4 modes we have been tracking over time here. This is the natural frequency we can see here. It's clear that something is happening around here. And we can see it if we amplify even more and only look at the blue one, then down here, we can really see that at some point here there are these jumps here. And this is a very nice, convenient way of looking at development of the, you could say, the structural performance of a structure, or the dynamic performance of it, and we can easily see when something is happening. We also like to define some thresholds based on the initial part here that allows us then to issue alarms the minute that we are now having so drastic changes that we come outside these thresholds here that we have made for this interval that we see here. So in this way here, this is all coming from the UPCX method. These intervals here are also derived from the uncertainties that we can actually get from using those methods. And this is also one of the convenient reasons of using it. There are different ways we can actually track, you would say, changes. And I try to write it here. There is an absolute change and a relative. And the one that is absolute, that means that we have an initial starting point here where we find through a range of results in time. Based on this, we try to find everything that is in common for this range here. We call it the reference range. And then we will average whatever is common there. This gives us what we call a reference mode that we will be tracking. And then the absolute change means simply that if the change of this parameter here is larger than a certain tolerance compared to that initial value, then we stop the tracking and say, okay, now we cannot find anything that looks like this initial mode anymore. But if we use relative tracking, it's simply we compare the previous with the next mode, and this allows us now to actually track how these modes are developing over time. And this is what you can see we are doing here. Instead of the absolute change or checking of change that is absolute, we have used the relative, and that allows us now to track, even though that this one here is going way below the thresholds, we can still track actually this mode here and the way it actually behaves throughout the complete measurement we have here. So this is relative mode tracking that we are using. We can also see up here there is a red one here. This one actually stops here. And this is simply because there is so much change that even the relative change is too high now so that we cannot track it anymore. So that means we stop here. And this is, of course, if you have significant damage, this would happen. So this is one of the way to look at the data. This is mode tracking. This works really nice if you could say the change that we have in our system is only related to structural change. There is unfortunately the problem that sometimes changes over time of frequencies, for example, is actually not related to you could say a damage, but merely some environmental or operational conditions that are changing from one measurement to another one. And here you can see a case like this. Here we have readings from around January and then to end of August. In this case here, what you see down here is average temperatures that has been measured along with the response measurements that has been taken on this structure here. So you can actually see here that we go from around, what is it? The minimum is minus 0.7 Celsius and then up to 21 degrees Celsius. So there is a span of roughly 22 degrees in this time we have measured in here. If you look now at the tracked modes, or one of the tracked modes, we can actually see the blue line you have up here. This is then this natural frequency of this mode here that has been extracted from all these different measurements that has been made in this time. And when we look at it, we can see there is a kind of a decaying trend. So as temperature goes up, the frequency actually drops a little bit. And that's because of, you could say, the environmental effects that the temperature has on this structure here. This is a bridge that has been measured. So we have actually also developed in ARTeMIS a way to account for this, because if we assume that there is a linear relationship between our frequency and then our temperature, we can make a linear least square estimation and then subtract this from the frequencies that we have estimated. And based on that, we assign some temperature as our reference temperature. In this case, we have put it as 0 Celsius. Then we can actually now compensate for the change of the temperature in the frequency. And what we get out of that is then the red line that you see here. That is more constant around the same line in this diagram here. We can actually see, if the only place where they more or less agree is that here around this point here, we are roughly around 0 in Celsius. And you can actually see the place where they actually look to be on top of each other is around here, which is because this is where you basically don't have any compensation. You are just using the raw measurement here because it is in fact at the reference temperature already. But this is some of the things that one has to do sometimes, but it of course require that you have to measure the temperature and any other operational values or variables that can affect the structure. So this is another point we have been working on to put into ARTeMIS. I would like to show you how ARTeMIS looks when we have done an analysis on a structure. And I have this example here that I've probably shown a couple of times before. This is a highway bridge that was measured. It was located in Austria. And there was some different damage being introduced over time. You can see different types of damage listed here. And everything basically was going on this pier here. So they started cutting out some of the concrete here and then lowering it and so on. And then in the end, they tried to lift it up and repair it. So this, of course, gives rise to different modes estimated. And then there was a recording system that was actually measuring all the time while this was happening. And we have a test case here where we have around roughly 700 measurement files available. So this one here, if we have a look at the modes here, you can see here how the first 4 fundamental modes looks of this structure here. This is a transverse mode that is going in and out in the transverse direction. Then we have a bending mode here and some torsional modes here as well. We can try to see how this looks if we load this into ARTeMIS. Let me just open ARTeMIS here. When we open it here, one thing you can perhaps notice is when we check it out here, then we get this this license checked out here. This is our Pro version of ARTeMIS. And then besides that, there are some plugin licenses here. You can see here, there are many of them in my case here, but you will see later on that these actually relates to some modules that we are using for this SHM. So I have all these checked out here, so I can actually open a project that has been created as an SHM project. And this is then this S101 project that I'll be loading here. Let's see here now. It has already been processed, so it takes a little time to load. There are many things that needs to be loaded into memory. But what we can see here now is something like if I click here on this mode analysis here, then we can actually now see this diagram we talked about before, where we are looking at the different measurements. We call it sessions here. So there is from the first one and then to the last one, there is 681 measurements analyzed here. You can, I don't know if you can see it in the screen sharing, but there is like a cloud here of dots. This is actually a lot of modes that has been estimated besides the ones that we are looking at, the 4 modes we are looking at. But there is, of course, a lot of other modes being estimated, and they sometimes are consistently showing the same place, and other times they are just appearing spuriously at different locations. So there are some that you could say we can track, and some we cannot really track so good. The ones that are being tracked are the ones we see here in these 4 colors here. And it's all based on that we have a reference range. This is then this dark, this gray zone here. Everything in between here has been used to find, you say, modes that looks the same in all these sessions here. And there are 4 modes that looks the same over these sessions here, and that's the one that we can now track in the software. And then besides that, there is of course all these different other things that you can look at here. All of this is collected in this task here that we call the analysis history task. This is the primary place, I would say, that we work when we work with ARTeMIS for SHM. We are actually here most of the time then. You start up in the other tasks to set up the project and do the initial analysis. But after that, you switch to this one here, and this is then where you can then see how this diagram here is developing over time. So this is a very short introduction to how an analysis looks when you have completed it in this SHM study we have done of this S101 bridge here. Let's go back here to the presentation. So you saw this analysis task here is something looking like this, and in order to get this you could say showing up, we need a special module activated in the software. We call this the data manager base module. The reason why we call it data manager is because it administrates all the measurements that we are importing and all the results that are being produced based on the measurements. And the presentation basically also of it, all that is how to access all this data here is administrated by this this module here. It also administrates where to store things. So storage in files, storage to database, and so on. All this is also administrated by this this module here. A project for SHM is a little bit special, you could say, in ARTeMIS compared to a normal project you use just for doing a single mode analysis with the software. In this case here, we actually have to split things up a little bit because we are producing a lot of data. And if you just put everything into the same big file, it will be a massive file. And it will be very impossible to work with and also move around with for the user. So we have chosen to split it up so that we have a master project file, and then we have files for each of the measurements that has been uploaded that will be called analysis sessions. That file or these files contains the raw measurements, the process measurements, and then the estimated results. So you can imagine for each of the measurements, there will be this kind of the file here. I can show you how it looks for this S101 here. I think I have the list of files here. So this is the file folder that I'm saving all the files in for this project here. I have my master project file here. This is the one we load from the graphical user interface also. But then there is a whole bunch of files here. They all called session something. And that's the different files that are containing these measurements and analysis results for a particular measurement file. They're having this ID here that is just growing. So this is the way you can look at those. There are some other files up here. The first file here, this is a stat file. This is the one that contains the statistics of the different channels of all the different projects. And that's we have made it this way to make it easy to access for the software, so that if you want to see the RMS value of channel number 1 for 1000 measurements, you can get it quite fast because we have it in this file here. There are these files here also called something with COV in the end as extension. This is actually used for the damage detection tools we have. It is stored in here, and you can see they are quite big, these files here. There is a lot of information that is required in order to do statistical damage detection. So this is a file folder where everything is collected in, but we have split it up into separate files in order to make it more easy to work with. And then one thing I just want to mention here also is that we have just, with this release we have made now, we have actually made it possible to, you could say, have some lightweight versions of this data manager base module. Before we only had one module, and it supported that you could load, I don't know, 100, 200 channels or something every time you had a new measurement file loaded. But to make it a little bit more affordable for people that maybe only have 16 channels, we have actually made some lightweight versions of this data manager base module here, so that if you have up to 16, 32 or 64 channels, there are different modules that you can choose among. And then of course there is the unlimited module also, there where you can have as many channels as you want. So there are different options available now. Now, in order to process all this data that you have seen, these 681 channels, you can of course load them into ARTeMIS one by one and then analyze them, but it's going to be a little bit cumbersome. So it's nice if you in some way can have a folder where your data is lying or it's coming in from the data acquisition system, and then having ARTeMIS looking into that folder and then looking for new data. And this is what we can do with a module we call automatic file upload module. This one allows you actually to configure ARTeMIS to look into a folder and then automatically load data and analyze data and save data without you having to sit and click around in the software. You can have the software open still so you can see what's going on, and it will also automatically update the different diagrams, but you don't have to do all the clicking with the mouse in order to find the different files you want to process. And this is done, the configuration of it is done through a dialog we call the SHM configuration dialog. Here there is this automatic import, and inside here you can now configure where do you want to look for files that you want to upload and process, what file type should it be, and how often should we do it, and what should we do once we have uploaded the file and process it? What should we do with the raw file then? Should we move it or delete it or keep it or whatever should be done? So there are different things you can set up here. And then once you have set it up, you can just turn it on and off as you like while the software is running. So this is a convenient way of letting ARTeMIS work by itself without having to do too much user interaction with it. We have this, I showed it before, and also in the software, we have this special module that presents the modes as a function of the measurements or sessions. And these diagrams here that shows modes or modal information like this, they are all related to a module we call modal parameter history. So this particular module opens up for that you can actually present this type of information here and save it also to files or to a database and so on. The way it works is that once you have the module, it's open up here, you can actually configure from where and to where you want to look for, you could say, modes that are in common to the different measurements here. This is the reference range I've been talking about. So you can simply select from where to where you want to look for something that is in common for all these different analysis that has been made there. So this is the way to produce reference modes, as we call it, which is averages of whatever is in common. So we find all the modes that describes this particular one here, that we have here in blue, and then we will average all of those. So we get an average frequency of this, an average damping, and an average mode shape. And then we have the initial starting point for this one here, and then we start searching for something that looks the same throughout all our measurements. But we need this initial mode estimated first, and that's what we call a reference mode. So it's a kind of an artificial mode. It's not one that has been measured or estimated. It's something that it's an average of something that we tell the software we think this is constant, what's going on here. There are no structural changes in this reference range. So go ahead and find anything that looks the same in this one here. So this is the first step that has to be done to make the mode tracking working. The next step would be then to search along all the measurements and see the different estimates of those and find the ones that looks the same as the ones we have in our reference range here. And this step here, this is where you can now check if you want to track with absolute difference compared to a reference mode, or it should be relative. So that are these different settings that you have to do here. And then once you have pressed the start button, then you will see that this search here is relatively quickly made, and you can easily see then what's going on. So this is mode tracking and modal parameter history. There is actually also a kind of a damage detection tool that is linked to this particular module here, and it's because we call it modal damage detection. And what it's doing is it's forming a vector for each measurement here of the tracked modes we have here. And then it's trying to, again, we start defining a reference range and then define what's going on in here. What do we have of information common to these? And once we have that defined, we start looking at vectors for each of the tracked or the analysis sessions. And we are looking for if what the difference between this reference range and whatever we are looking at, how big are the changes? What is the distance between the two? And this is then a damage detection, damage indicator that we are getting estimated. It's called Mahalanobis distance measure we are using here. So this is a damage detection tool that is derived directly from the modal parameters that has been estimated throughout all the analysis sessions. So this is all of this is a part of this specific module here. We actually also have a specific damage detection module, but that one is you could say here we have designed the damage detection tools to work with not the modes, but we are trying to actually fit a state space system that contains all the dynamics, you could say, between 0 and the Nyquist frequency we have measured with. And then we are looking for if we have a state space system that has been defined based on some reference measurements, and now we have some measurement somewhere out in the future. We are forming a similar state space system out here, and now we are looking for the difference between these two. So we basically subtract them from each other, the two models we have here, and then we are looking at the residuals or the differences between them, and then looking at how big are these residuals actually. So as long as the difference between these two are small, everything is good. We are below or in the lower end of the damage indicator values. The minute that this new system out here deviates from whatever we had in our reference, we will see an increase of the distance and an increase of this damage indicator. And that's what we can see in these diagrams here, that as long as we are green, that means we are under a threshold that has been defined as a part of setting up this reference state model, as we call it. And the minute we now get a damage that changes the structural system, we see that the distance is now larger. We cross the threshold here, and the indicators, they turn red now because they are above the red threshold. And of course, this is an indication that the structural change has happened to this particular structure here. So this is a statistical based damage detection that we have, and there are different tools available by using this module here. And it all works in parallel. Mode analysis, damage detection, and whatever it is, it's all running in parallel as long as when we load new data, all of this is done so that we can get, you could say, results out at the same time in the end. So this was a little talk about the modules, you could say, that we have that can produce results that we can use for assessment of if the structure has changed its dynamic behavior or not. Now let's talk a little bit about how can we make most use of a license that we have purchased. You could say if you install ARTeMIS and you then have a measurement system that is now measuring every hour or so and putting measurement files into a folder, and you have instructed ARTeMIS to look into that folder and load and analyze data, then while it's doing that, you should basically not touch the ARTeMIS. Because the minute you start doing something, you will interrupt some of this that is going on. So it's best if you can have a license reserved for, you could say, the number crunching, and then make that produce the results, do the actual monitoring of the different structures. Another thing that you might also have of a challenge is, let's say you have 5 structures that you want to monitor. So now you have measurement systems monitoring this or measuring on it, dumping files into 5 different folders on your network somewhere, and you have your single ARTeMIS license. If you want to run that, then you will have to start opening one project manually, load data in for that particular project, analyze it, save the results, save the project, close the project, then go to the next project, open it, and do the same one more time. In this way, you can then, you could say, reuse your single license for different structures that you are monitoring. Instead of having to do this manually again, we have designed a service, a Windows service, that can actually do all this by itself. We call this the SHM Automation Service. So you can imagine you have an installation of ARTeMIS Pro that is doing all these different things that you have configured. So you are using the different modules that can produce results. And then you have the different structures that you are measuring. They are dumping files into folders. And then you also have an SQL database somewhere where you would like actually results to be stored so you can access them outside ARTeMIS Modal. So the service here actually try to embrace all of this. It simply is installed along with ARTeMIS, and you can then go to Windows Services on your machine. And then there is something called ARTeMIS Service where you can just start it whenever you want to do that. And then before you do that, then you have configured that there is a range of different projects that you would like this service here to work with. So you make a kind of a tree structure here where you can define some names, and then all below that different projects perhaps that you want to analyze for it. And then you save this. That is then saved into an XML file that is lying on the computer where you're running ARTeMIS. When you then start ARTeMIS service up here, it looks into that XML file, and it now starts to process all these different projects that you have defined here sequentially. So it takes one, it opens the project, it opens the data files for it, it analyzes, and it save result, and it save the project and close the project and move on to the next. This is done automatically just over and over again, scanning all the different folders every time so that new data coming in is being processed as fast as possible. Of course, there is a limit to how many structures we can analyze like this without delay. This depends on, you could say, different things. It depends on the computer you have installed it on. It also depends on the size of the measurements you are moving in. It also depends on the kind of file format you're using, because if you're using an ASCII text file format, it is just much slower to work with than if you have a binary format. So there are different things that in some way relate to how many different structures we can actually analyze at the same time. But we have two different licenses available. One with 5 structures that you can make work in this loop here, and one with 10. And after that, we do not really guarantee that you can do more, but it's really dependent upon you could say the performance of many things, as you can imagine. But what it does, this service, is simply to repeat everything that we see here, the whole analysis, storing of the results in database and perhaps in files and so on. This is now done completely automatic without the user interface open. You cannot see ARTeMIS. It's just running as a Windows service, but it's a really effective way of running the software, because in this way we disable all this notification we need to have inside the software to update all the different diagrams and all the things. All this is actually now disabled because you are running it as a kind of a hidden program. So this is the SHM automation service. This is a special license that one can add to, and then it opens up for all this, that you can actually use a single ARTeMIS license for multiple structures in a very effective way. You can see over here there is a part here that I did not explain now, but of course we would like also, while we are doing or the service is actually producing results, we would actually like to be able to view it and see what's going on. And that means that we need to have something for the clients to look at. And what we have developed is a kind of a viewer, or it is a viewer. It is ARTeMIS that you install, but it's in a viewer configuration that allows you to look at this analysis history task in a read-only manner. I can try to show you here. I can link it up to another computer through a team viewer here. Then I can show you here. So this is another computer running here in another office. If I now start ARTeMIS here, then it has to look through and find a license. And now you can see ARTeMIS here, but it's a little bit different. There is something here we haven't seen before. Down here you can see it says another type of license here, DB Viewer something, has been checked out as the only thing right now. So that means that this ARTeMIS instance here is running as a viewer, which means that many things are disabled, but the things that we would like to do is to view results from the database. So I can try to log in. I'll just write some credentials here. Hope I can remember them. And now you can see something coming up here. This is a map. Everything you see here is coming from the SQL database. It's not from a project file or anything. It's something that has been saved from the original or the full license ARTeMIS into the SQL database, and we are now, you could say, reading that and presenting it here in this instance here that is a viewer. So right now in this this login I gave here, I only have access to a single structure, but it could actually be many different structures. But there is this S101, and it's lying here. Let's see, somewhere here in Austria, as you can see here. So I can double click on this one here. I can also click on the list you saw down here below. And now I get into the analysis history again. And you see, perhaps it looks very much the same as we saw before, where it was the project that we have opened. But now it's simply a result coming from the database that we have linked up to. And again, we can try to just have a look at. Now it reads it from the database instead of from the project. So now we have then the same information as you have seen earlier. We can also have a look at modes, and I guess we have a geometry here somewhere. So we can have a look and we can animate modes just like we have been doing in an ARTeMIS project, because we are using exactly the same, you could say, controls that we have, but now for information that is actually retrieved from a database. So this is the viewer that we have developed. It is something that replaces a web portal that we had made as a kind of a prototype, but we believe this is actually a much more effective way of working with the data, because you are looking at in exactly the same environment as where you produce the results. So the idea is that you download ARTeMIS on the client computers where you want to view the results, and then there is a floating license that gives you access to this viewer here, and you can then have 10 or 15 of these licenses for this viewer here, and that means you can have 10 or 15 people looking at the same information at the same time, or different information at the same time. So this is the idea with this viewer here. And I think I just have a slide that just, oh, that was actually the one I have here. So this is what we have introduced here, and you can see that we have these different multi-user licenses created here for this. So you don't need anything except go into ARTeMIS download link at the website, and then you can download this. And then immediately, once you have this viewer license, then you can open up for any database that you have access to. The way access is provided is by the user of the full license of ARTeMIS, where the actual project is being created. At this place, there is actually a management part for these viewers. So the manager there, or the administrator there, he can actually create a special license that allow this viewing here. I think perhaps I'm not sure where we have it. Could I find it here perhaps? I think perhaps if I go here, you can actually see it here. This is the file that you will be sending as an administrator to anyone that is supposed to look at this particular database here. They will get, of course, instructions to how to download ARTeMIS and install it, and then how to connect to the license server. But then the information that relates to the actual database that one can open is simply put in this little file here. There's a binary file that people, they just have to search for when they open this viewer here. And then they have been told what the credentials are for logging in. And then the connection is created in this way here. So this is the viewer. Finally, I would like to just present, if I can be allowed, the last thing we have added now in the latest version. It's a replacement actually of, you could say, a product we have earlier had in a separate executable for batch mode processing of results. Now we have depreciated this product. It's called ARTeX, as you can see here. This will no longer be supported, but we have now put the functionality into ARTeMIS Modal Pro, which means that everyone that has a Pro now can actually run it in a batch mode way, which means that you can run it from a command prompt like I have shown here, and then you can simply type in the ARTeMIS name, indicate that it's a batch mode that you are running, and then have a keyword called project, where you then after that you tell what configuration file you are going to load this project from. And this configuration file is the normal way we can define an operational mode analysis project in ARTeMIS. The only new thing I would say for at least some is that there is a section in this configuration file called properties, where we now can add all the different signal processing and storage and loading options that are required in order to do something without, you could say, user interaction. We use it extensively in everything that relates to SHM, but we also use it when we export a project from ARTeMIS into a configuration file format. Then all the settings that you have made in your signal processing, they are actually written into this section here, so that next time you open it, decimation and whatever it is has been configured. It will be configured the same way as the project where you actually exported this out from. So this is a way to put in the different settings, properties that are needed in order to do a batch mode processing. And you can see here that what we do is we can tell what estimators we want to use, and you can use multiple of them as long as it's SSI estimators. And then you can also inform where you want results to be stored. And you can put here a kind of a prefix to the results files that are created. So that could be, you would say, a kind of a prefix that describes the project you are working on. Then you can also inform that you want to, in fact, store modes. And you can then also put the different formats you would like modes to be stored in. That's also possible here. New things, well, it's also, we can actually export the full stabilization diagram, and also statistics can be exported. So there are different things that was not available in the old batch mode. But all of this is now available through this configuration file, where you simply define what it is that has to be imported, of course, but also what should be processed and what should be exported. So this is just an introduction to that there is this new feature available if you want to run ARTeMIS on a command line, which is it can be used actually as a kind of a lightweight SHM solution, because you can then integrate it into, let's say, MATLAB or something else. If you want to have a kind of a loop running all the time, you get new data, you can then form a new configuration file and then call ARTeMIS from a command line like this. And there's no, in that case, of course, no user interface opening up or anything. So this can be done completely transparent in this way. So this was just a little bit additional news we have in this version we have released. So my final remarks here is simply that I have tried to give you a little introduction to what we can do with ARTeMIS Modal when it comes to long-term monitoring, what we can do when it comes to loading files automatically, and do automatic analysis like the mode tracking also that I've been talking about, and damage detection, and all the different ways to export results. There's also notification services. I did not really talk about that today, but of course you can set up that you want to have emails or SMS sent out whenever something happens. And then I talked about this automation service that allow you actually to use a single license for, you could say, analyzing multiple structures in an effective manner. And finally, we have our database viewer. This is a new thing that we have added to ARTeMIS Modal that allow you to use the actual platform for viewing the database results. So this is what I wanted to talk about in this webinar here. And if you want to have more information, as usual, you can go to our YouTube channel, and you can also visit our website. And then there is also a user training course coming up here in 1.5 months from now here in Aalborg, and we are still having a few free seats available. And then finally, we of course have our next webinar, which will be in the end of April. That will concern the new development we have done in experimental mode analysis. So thank you very much for watching.